but I wanted to talk a little bit about a problem that I saw in the exam, and I think it's something I didn't explain too well, and that is if it says that's geometric series, and so I'm only talking about when the series converges. Okay, so when absolute value of r is less than 1, what it converges to. And I took the a out because, like, if you have an a there, then just multiply everything by a. Okay, so if you're summing from 1 to infinity, then it's going to be r over 1 minus r. But what if you're summing from 0 to infinity of the same thing? Well, that's a little bit tricky but here's the way that perhaps you can think about it for now. If you're going from 1 to infinity, then if you're going from 1 to infinity, then that's like r plus r squared plus r cubed and so on. Because when n equals 1, you plug a 1 in right here into the equation and you get r to the 1. When n is 2, you're plugging a 2 in right here, you're getting r squared. When n is 3, you're getting this, and so on, going up. This right here, you're starting from 0. So when n is 0, that's like 1. And then you have all this other stuff. Okay, so you have to be careful about using the formula. I'm just pointing that out. Because if it depends on where it starts from. Because, like, you can see that this sum right here, or this series, is going to be different than this one because this has an extra 1 right here that this doesn't have. And now all this, in this case, all this is going to be, is just going to be this. So all this gives you r over 1 minus r. But you still have this 1 right here that you're adding to it. Okay? And the 1 is going to, you can get as it gets 1 minus r over 1 minus r. Or not 2. So if you add these two together, the r's cancel in the numerator, you just get 1 over 1 minus r. Okay, so if it starts from 0, that's 1 over 1 minus r. Now, if you go, another case that might come up with where you've got this weird thing going on. Okay, this is r to the n minus 1. So that can confuse a lot of people. That's really nasty. Okay, so when n is 0, this is what? It's r to the minus 1. Oops. Dang. And then when n is, this is when n is 0. When n is 1, you have r to 0, which is 1. And then when n is 2, you have
I figured it.
r.
He's in the wrong one. He sent an email.
And then it just keeps going up from there, right? Okay.
What the heck, brother hers?
Yeah. Okay, so this case, so it's good to write down the first few terms and see what's going on. Now, if it was just this part, then, well, that's just going to be r over 1 minus r. But you have all this stuff too, right? So what you can do is, another trick that you can do is you can factor out, in this case, it would probably be good to factor out 1 over r squared, okay? Because this guy right here is really just 1 over r. So you factor out 1 over r squared, then that leaves you with actually an r. Because this times this is 1 over r, right? Okay, and then all this is r over 1 minus r. Okay, so you're just going to get, so when you're multiplying these two together, you get that. Okay, so that's one way you can do that. So that's how you can do that. Now, Another situation would be if it starts from some weird number, like let's say it starts from 5, for example. Okay, so then you're starting with 5. Okay, so that's going to start with r to the 5th, right? And then when n is 6, you get r to the 6th. And when n is 7, you get r to the 7th. And just goes up from there. So you can apply the same sort of thing to this by factoring out an r to the 4th. And then you have r plus r squared plus r cubed and so on. And then you know that all of this right here sums to r over 1 minus r. Okay, so then you just get r to the 5th over 1 minus r. Okay? So those are just some things to be careful about. No, you have to notice where the series is starting from. Okay, any other questions before we get started with what we're doing today? Dang, only 5 people. Oh, well, thanks everybody for joining. Okay. So what today's all about is just kind of reviewing the different methods that we learned. So here's the integral test. And in order to apply it, you need your terms have to correspond to a function, and they all have to be positive, and you have to be continuous and decreasing. And then if you have that, then this series here converges if and only if this integral converges. But you have to have the conditions. Okay, then 11.4, we're talking about different comparison tests. So sequences. And the most important one is the limit comparison test. Well, the other ones are important. The other ones are like, and the important thing is that you're comparing the terms in the sequence. Okay, which is larger, the ANs or the BNs? You're not comparing the series. You're comparing the terms, not the series. Okay? I'm here. And Siri, shut up. Okay, so the limit comparison test is you're messing with the terms in this and you also need the terms to be non-negative. Dang it! I shut this in the cabinet and it still picks up that. Okay. Okay, then we have 11.5, which is alternating series. And here your terms are like, you got this -1 to the n, or it could be n plus 1 or n minus 1, and then you have these bn's. And the bn's have to go to 0, and they have to go monotonically, meaning that they have to be steadily decreasing. You can't have anyone that's stopped. You can't have anyone that's larger than the previous one. Okay, and they have to converge to 0. And if that's the case, then it's going to converge. Okay, then we have the ratio and the root test, and they're both go off this, and then this determines. Now, when you do get the inconclusive one, or L equals 1, then comparing with the p-series might work. So that's something to look for there. And finally, wait, there was something else that oh, there's this right here. That's usually the first thing that you check. the terms go to 0. Okay, because if they don't go to 0, then you can automatically say that diverges. Okay, but a lot of students in my classes, and I try to emphasize it now a lot so they don't do this anymore, but a lot of students would be like, oh, the terms go to 0, it converges. I'm like, no, that's not enough to determine that the series converges. Okay, you also need, they have to be going to 0 fast, at some kind of a fast rate, not like really slow rate. Okay, so let's get on with the homework. Whoa. Okay, so let's get on with the homework. Number 1. A lot of true-false questions here. What do you think, converges or diverges?
Diverges.
And why? It does, it diverges.
Because the power to the n increases a lot faster than n squared.
Yeah, that actually goes to infinity, as n goes to infinity, right?
Right.
It doesn't go to 0, so it doesn't go to 0. So that means it's going to diverge. Okay, so divergent.
Hi, by the way, I just logged in right now.
Yay, thanks for... Hi. Okay, now number 2. Okay, anybody want to make a guess? But don't put it in your thing and then see what it is and then guess. Now, what do you think? What would be a good strategy? Maybe that would be a better question. What would be a good thing to determine whether this converges or not?
Taking the integral, maybe.
The integral, right?
Yeah.
Dang, can we do that?
Maybe. Teach us.
Yeah, what was I thinking when I put this problem on there? I thought there was a clear way to do it, but now I'm not. I'm like, what? Okay, so let's try this. Let's try the integral. And it goes from 7 to infinity? What's up with that? That's weird. Okay, so we have 1 over n, and then we have ln of 5n to the negative 1/2. So I'll write it like that. Okay. Also, instead of n's, let's use x's. It's an integral, so I should use x. Okay. Dx. Okay, so anybody know what the integral is going to be? Anybody? Just a second, someone knocking on the door.
Do you do voodoo?
The U substitution, probably.
Yes, a U substitution is good. So if you so think U is log of 5x, because that looks like the nastiest part, right? And what's du? If you take the derivative.
Yeah, 5 over x.
So it's 1 over 5x times the derivative of that, which is 5. It's just actually going to be 1 over x, right? Whoa.
What?
Yes, 1 over x dx. And it just so happens that we have a 1 over x, although the x is kind of in a prison right here. I don't know how to get it out. How do I get the x out of the prison? Oh, well, don't worry about that.
You don't.
You don't get it out. Okay, yeah, we just won't worry about it. Maybe it'll get out on its own someday. Okay, so that means that the integral is just going to be log of 5x raised to the, okay, so if you add 1 to this, you're going to get 1/2, right? So if you take the derivative of this, you'll have a 1/2 come down. So let's put a 2 there to counter that. And then this will reduce by 1 to give you that part. And then then the derivative of this inside part is just going to be 1 over x, which is right here, dx. So that looks good. And then from 7 to infinity, okay, what's that going to be? It's the number that starts with an I.
Infinity.
Imaginary.
It's infinity, not imaginary. That means
I tried.
that means that it's divergent. Diverges. Hey, should we keep score here? Let me see. We have, ooh, diverges is winning 2-0. Look, that number 1 diverged and number 2 also diverged. All right. Did you guys know that, did you guys know? No, you didn't know that. And it doesn't matter. Okay, never mind. Okay, so let's look at number 3. So here you have sine 7n over 1 plus 5 to the n. Okay, so what can you say about sine of 7n when you see it in this kind of situation?
Isn't it going to oscillate?
It's what?
Isn't it going to go back and forth between like 1 and -1 or something?
Yeah. So so the most it can be is 1, right?
Right.
Okay. Now, so the most of the numerator can be is 1. It's probably never going to be 1. So I don't have to have this right here, but okay. And what about the denominator? What about 1 plus 5 to the n versus 5 to the n? This is larger, right?
Mm-hmm.
But since it's in the denominator, that means that this, even if there was a 1 right here, this would be smaller than that. Okay? Because it's like, okay, we have some pi, we have to share it with 1 plus 5 to the n people, but then this 1 is gone, so we only have to share it with 5 to the n people, so that means more pi for everybody, right?
Yeah.
Yay.
Although the amount is not that much, especially if n is really large, then it doesn't really make that much of a difference. Okay, and so now, what do you think, converges or diverges? What does this series do?
Convergence.
1 over 5 to the n.
Doesn't it go to 0?
Because that's a geometric series with r equals 5. So by comparison test, the original one converges. Okay, so this is exciting. So converges has 1 point now. Yay! Actually, let me verify that with the referee here. That's the WebAssign referee. Yep. Okay, so
Brother Hurst, when you find b sub n, which is 1 over 5 to the n, you only have to look at that to see if it converges, and if that one converges, then both of them will converge.
yeah, because these terms in absolute value are smaller than this. So if
Okay.
this converges, then this will have to converge too. Now, if this diverged, then this would be inconclusive because we're saying it's less than or equal to something that diverges. Well, it can still diverge, okay? But if it's less than or equal to something that converges, then it's got to converge. And I'm using opposite values there, okay? So essentially what I've done is shown that it converges absolutely, because this can be negative. This sine 7n it's going to take on negative values and positive values. So, but it's not an alternating series because it doesn't go back and forth consistently from every other term. Because it could have like 2 positive terms and then a negative term and then, or something like that. Okay, so number 4. Something weird like this, what do you think we should use here? What test would you use on this one?
Ratio.
Comparison.
What would you compare it
Good question.
with?
Oh, wait. What was it? I have different.
You could use comparison, but usually when you see something like this, you would use something else, or something else that you would use that starts with an R. But a comparison would work if you know.
Ratio test.
Yes, the ratio test. So that's what you'd mostly use because, dang it, I hate that put that box around my stuff. Ooh. Okay, so limit as n goes to infinity of a n plus 1 over a n. Now, you know, you need absolute values, but this one you don't actually need them because all the terms are positive. So if you're having the n plus first term, then that's going to be 3 times 7 times 11, all the way up to, you're going to have this for n minus 1, but then you're also going to have 4 times n plus 1 minus 1. And then down here, you're going to have 6, 13, 20, and then all the way up to 7n minus 1 times 7 times n plus 1 minus 1. And then down here, you're going to have 3, 7, 11, all the way up to 4n minus 1. And you're going to have 6, 13, 20, all the way up to 7n minus 1. And then now what happens?
They cancel.
All the coefficients cancel.
What? A lot of canceling?
Yeah.
And what are you left with? I don't know how to change color. How do I change color with the, because if I change color now, then it just changes all that. Changes all the previous stuff. I don't know how, oh well. Actually, let me see something. Go to the previous page. Come back. And change color. Okay, good, there we go. All that is going to cancel with all that, right? And all that cancels with all that. All that. All the whole denominator got taken out. And we just have 4. And let's see, this is 4n plus 4. And so that's 4n plus 3. And then down here we have 7n plus 6. Okay. So what happens as n goes to infinity? What does this go to?
4/7.
4/7.
4/7. Okay, and then what's important about 4/7?
Less than 1. So
It's a number.
It's less than uno, right? So that means
Version.
converges. Okay, so now, let's see, the tally. Well, this is getting exciting because now it's 2 to 2, right? Okay, number 5.
So, Brother Hurst, this whole section is just reviewing all the different ways we can find if it converges or diverges.
Yes, that's all it is.
Okay.
Just going over the previous stuff. So the idea is that previously when you did it, it was assigned to that section, so you knew that that's the method, or maybe there's like 1 or 2 methods. So you know that you knew that those were the methods, but now you don't know. So there you go. Okay, number 5. Oh dear. Okay, so what should we do for number 5? What do you think would
Alternating
be good?
test.
The what?
The alternating series test.
This is alternating series?
Oh, wait. I'm looking at the number 6. My bad.
Yeah, number 6 is alternating series. Okay, so this one is
Comparison?
comparison.
Maybe.
Yes, comparison.
Thank you. Yes.
What do you want to compare it with?
K cubed. Actually, maybe K squared. 1 over K squared.
Compare this with 1 over K squared?
I think.
The log K kind of messes you up though.
Oh, I
The
didn't
log
see that.
K.
I don't know how. I
Yeah.
don't know what to do there.
Yeah, the log K is kind of tricky. But the log K, you just kind of have to have the idea. You have to kind of have the idea to realize that the log K is really weak. So log K is like really, really weak. So like if you had log K versus like K to the 0.0000, like you could add as many zeros here as you wanted, then this would be the winner. Eventually in the end, you know, as you go to infinity, this goes to infinity faster than this does. Okay. So what you can do is, I would say, here's one thing you can do. Limit comparison. And you made a good point in that this plus 7 really doesn't matter in the end. It doesn't really affect convergence or divergence. So you've got this K cubed here, and you have this this log K. You could just replace that with like 0.01, for example. Okay, because that's still going to beat out your log K. And so essentially that would give you that would give you 1 over K to the 1.99. Okay. Okay, so now the thing is, if you do that, now you are dividing by this. This and this just cancel each other off. And these cubes also The cubes also cancel each other off. Change colors and come back. I don't know how to change colors here. Those are also just kind of cancel each other off, just like that. And so then really you're just left with log k over k to the 0.01. And if you try L'Hopital's rule, you get 0 pretty quickly. Okay, so that's going to be 0. That means that, so that's like what I said, you know, where this one eventually beats that one out in the end. Okay, so k to the 0.01 is going to beat out the other one. Okay, so what the heck? What? Oh well. So that means what's it gonna be? So that's 0. Ooh, what does limit comparison test say if you get a 0? And you get a 0, and what's that?
Converges?
Yeah, converges, because this right here, this one converges by, so since 1 over k to the 1.99 converges by p series,
What's a convert?
it equals 1.99, which is greater than 1, then by limit comparison, we'll call it original series converges. Whoa, hold on a second. Does that mean, does it converges actually took the lead after falling behind 2-0? Now they're winning. Oh dear.
It does. Oh, dang.
Goodness, 3-2. Okay, now number 6. What happens here? Number 6. So you have, and then Taylor said use alternating series, right?
Yes.
So what happens with alternating series?
Doesn't the first two values, when you put them together, have to be negative in order for it to be convergent?
The first two values?
Yeah, so you like plug in 1 and then you plug in 2 after, and then if you add them together, or am I just not making sense right now? I'm not making sense.
Oh, you don't need that. So what you're looking at is that it alternates back and forth. And this right here gives you the alternating.
Okay.
And well, it's not just that, it's just that and the fact that this is always positive. The rest of it's always positive. Okay? So, and then this guy right here, the limit as j goes to infinity of the square root of j. Over j plus 7, what's that? What's that limit? Which is better, j or square root of j? Which is good for the faster.
J is bigger, so
That's going to be 0, right?
0.
So it's alternating series, and it goes to, these other terms go to 0, so that means, and they go to 0 monotonically, meaning they're decreasing terms. So that means it converges by alternating series.
So it converges because it goes to 0, or because it goes down in, it's a decreasing series, correct?
Yeah, this part's decreasing, and then this part here makes it alternating.
But
Okay,
if
this is
it diverge.
what you thought it diverged.
If it was an increasing series, then it would diverge. It would fail the test, correct?
Right. If the terms don't go to 0, then it's automatically gonna diverge. Okay. So also in this particular case, if you didn't have that, if you didn't have this part to it, okay. So let's say that just a second. Let me change colors. I'll try that color. Okay. Okay, so what the? Okay, so if it didn't have that part to it, so let's say it were just like this. This would diverge actually. And why would it diverge?
Because
So if you ignore the +7, you have the square root of j over j, right?
right.
Which is the same j to the 1 over j to the 1/2. Okay. And that's a p series with p equal to 1/2, which is less than or equal to 1. Okay. So that's why that would diverge if that term wasn't there. Okay, number 7. What should we use on number 7? Any ideas?
Looks like a convergence,
The what?
because the bottom is bigger than the top. A convergence.
No, it would just go to 1, wouldn't it? Because it's like
No.
infinity over infinity, but then it's the n squared, but it still goes to 1, doesn't it?
You think the terms go to 1?
I think so.
Okay, well that's actually they don't.
What about the integral?
So
What?
what, Taylor?
We haven't used the integral test yet, so I'm guessing maybe the integral test.
It's gonna go to half, like 2 in the bottom, 1.
No, it gives you something that's not very fun to integrate.
No.
Let me give you there's another test we haven't used either, but let me give you a hint. Okay, so the terms, this can be written like this. So the n squared can be split up like that, see? Okay, so now, have you thought of the test that we can use?
Nope.
Root test.
Root test, right?
That's what I said.
It's the limit as n goes to infinity of the nth root of an, which in this case, nth root's just going to take that n out. Okay, now this is kind of weird, okay, because you still have this, it's still raised to the nth power, right? You just took that n out. It's not raised to the nth squared power. But let me do this, okay? Instead of solving that one, let me show you something else. if I take n plus 1 over n instead. So how is this related to that? How is this related to that? It's a reciprocal, right? Okay, so now I can split up like this. This is 1 plus 1 over n. Okay, now this is something that at least one person should remember what this is.
E.
E.
That's E, right? So that means that this is
Convergent.
1 over E. And then 1 over E is
Less than 1.
One, so it's convergent.
Yes.
what? This is crazy. Okay, so hold on. I'm gonna be nice here, and this right here was actually the diverges has a victory there.
What?
Yeah, we're just kind of making stuff up as we go along. But okay, so now it's 5-3. Okay, so anyways, the converges has clinched victory. Yay. Okay. Okay. Maybe is that why they call it like the World Series? Is it because they were like, we're doing series first and like making games with series, like what we're doing, and then let's do the same with with baseball.
No.
No. Okay. Okay. Okay, so we got here. It's down to the last one. Which, if it was baseball World Series, we wouldn't be playing this number 8 because like Convergence would already have won. But this is different. Like you guys said, it's different. Oh, it's different because you guys said we have to do this one. Okay, so what do you think is going to happen to this? Or what can we do? Okay, so when you see this cosine squared 7n, what do you think? This is going to be all over the place, right?
Yeah, it's gonna isolate also.
But it's going to be between what and what?
0, 1.
0 and 1, right? Because cosine is always between -1 and 1.
Right.
So cosine squared will always be between 0 and 1. Okay, so this is actually going to be divergent. So, but in order to show that, in order to show divergence, you need greater than something, which doesn't really, seem that possible. Because the idea is you want to drop this, right? You want to just drop this, and it's 1 over m. But if you just drop this, then you're making it larger. Okay, if you just drop that. So the first instinct might be, if you're more experienced with this, might be to just drop this part, and you have 1 over n, right? This diverges, right? But then you can't use comparison because this diverges, and then this is smaller than something that diverges, so it doesn't show that it also diverges. You can't say it also diverges. Okay, see what I mean there? What I'm saying? You have to actually get it greater than something that diverges. And this is a little bit tricky. But you know, this is between 0 and 1. That means it's less than, that means that this is always less than or equal to 1. So you can put a 2 in there. Or maybe I should write it like this. n plus n, which is 1 over 2n. Okay, and then what can you say about this right here? 1 over 2n.
Calculate them or something, so it would be easier for us to explain.
That's the same as 1/2 times this series. And what does this series do?
Oh. Infinity.
Okay, so diverges. So here you have it bigger, the term is bigger than the terms of a divergent series, so diverges by comparison test. Okay, diverges by comparison test. So that's so the last one is divergent. And what's the final score? 5-4. Okay, great. Are there any questions? Oh, whoa, time is up.
Sick. That was awesome. Thanks for the awesome lesson.
Okay, thank you guys for joining.
Thanks, Brother Harris.